This is from Altronics. It's a Logic Probe kit, as you can see. Interested with the run date, this was the 31st of the 8th 15, so I think it's been kind of sitting around for a while, but needless to say, we're going to have a go at building this and putting it together, and then we'll go and test it and see if it works. We've just opened the kit up and laid out the components, as you can see over here. You get electronics reference sheet, and that just gives you some general information on, your resistor color codes, whether they're in series or parallel, the printed circuit board track widths, your static precautions, power, Ohm's law, etc. So if you're new to kit building, you'll probably find that handy. A whole heap of information inside on various components and their right values, etc. A handy sheet to keep if you haven't got that information or don't have access to it. It's good to read through this. You can see the right schematic there for the kit and the general layout once it's completed. They've got the printed circuit board assembly, making, fitting the probe, your final heat shrinking, testing, etc. And then it's just got some general right photographs of the kit being constructed, and some information on your conductor codes, capacitor codes I should say. So once you kind of read through all that, next step is really just to go through your parts list, check off your parts against your parts list to make sure that they're all there. And then once you've done that, then you're going to have to go through your parts, and what we do here is that we'll go through and check each of those. We'll check the resistors, make sure that they're okay and in tolerance. We'll go through the capacitors, do the same. You can check your LEDs, diodes, etc. You've got a integrated circuit there that's supplied. I haven't looked at what type that is yet, but we'll do that in a second. Printed circuit board, some heat shrink, a probe, and you've got battery, switch. They supply some solder, and we've got some leads here. So what we've got here is a 4001. It's just a quad NOR gate. So we're just going through and testing the resistors. The first one that we got there is our 10 meg, so that's checking out okay. So now we're just going through and checking the diodes. So it should be open circuit one way, and if we turned around and put it on the other way, you should get about 0.6, 0.7, so that's correct. You can see this one's showing 0.6 or a little bit over, and if we reverse it, it should show open circuit as it does. So now we're testing the right supplied capacitors. This one's supposed to be 100 nanofarad, we're getting 97. So you never get exact readings on these. Alright, so this is a little LED test we made up some time ago, and you can see here that we can test the LED. The LED is on, and also the red light is on, saying that it's okay. And if you go the other way, you can see you get nothing, which is correct. So when you're testing these, the shorter lead is your cathode, the longer lead is your anode. You can see there that we're getting it working there. So what we're going to do now is just go through and give the board a clean. We're using isopropyl alcohol, so we're just going to brush the board over, make sure that the board is clean and the contacts are clean. You just end up with a better soldering job, and the whole issue behind soldering is basically cleanliness. So you're looking at the board that way. With reference to the board itself, we're just going to use that as a reference for putting the components on. But the general idea of putting the components on is to put the smaller components on first, and then the higher ones or the bulkier ones on later. So the first thing we'll put on are the diodes, and then the resistors, and then the IC bed, probably the battery. After that, the diodes, the LEDs, and then the capacitors. So it's basically the order of attack. So we've got to put two bridging links in here. There's one there and there's one there, and they've supplied a bit of wire to actually do that. So the first thing I tend to do when we're doing these is I'll just get the wire, and I'll put a bend in it. Then you can place it into the position where you want to solder. And once you've got it in that position, then what you can do is with your pliers, you just come in so it's just touching where the bend's got to go into, and then bend it like that. And if everything worked out alright, we should be able to just poke that one through there, and the other one should fit through there. Xenon diode, and as you can see here it's laid in that position, that's its position there. But it's always good to check that you've got the right orientation. If I take that out, that's where the cathode is, and that's the orientation that we actually have it. So when you put it back in, so your cathode's on that side. But it's also good to check against your schematic. You can see here your cathode is going between R1, R2, and I'm not sure if you can see through the board, but if the light's shining through the cathode, there's a track on the other side there that joins up to R2 and then joins up to R1 over here. So we've got it in the right orientation. The next one is the second diode, which is the 1N4148. So you can see here the cathode is on the right hand side, and that lines up, so we can actually put that into position. So the components we're putting in now are these three resistors here, R4, R6 and R5. And you can see them laid out here right on the board, and we just got them sitting flush on the board, as with the diodes as well. We're at the stage now where we've got our two links in, our two diodes in, and now we've got all the resistors in position. Notice how we always orientate it that we can read the resistors from the same position from left to right, and we've done the same thing, with this orientation here. So from left to right when you're facing that way. We put the supporting pins in on the right front of the probe there, and we've got the LEDs in and the capacitors, as you can see here. And next is the switch, so we'll put the switch in and then we'll try to get the probe organised. So what we're doing here is just putting the probe into our small vise, and we've got to measure in 4 centimetres. This doesn't have to be exact. So I'm just going to come in with the ruler, put a mark, and then just follow that mark down. Just do a straight, even cut. It's not hard material to cut through, as you can see. Take your time and you get a nice cut on the end of it. So I'm just using a bit of sandpaper here just to smooth it off a bit and just round off that round edge. So as you can see, we've cut off the probe to the length. We ended up being 3 centimetres, not 4. We found 4 was too long, and the piece of wire that they supplied with the kit probably would have just made it, if that. You got your 4 pins, they're basically just guides. You got a pin at the back here, which is what this wire will secure to. The wire itself is, is pushed through and threaded through, and then this collar just screws back over that wire, so that's actually your connection between here and the probe. And what we'll do now is we'll fit that into here, and then we'll solder that onto the pin. Alright, so as you can see, we've got our switch in, we've got the probe placed in position and secured. They just do that with a couple of cable ties, as you can see there, and the pins are just guide pins to keep it like reasonably straight. And we've brought the wire out. The wire's been soldered to this back pin. So as you can see here, the cable came with 2 alligator clips. Right, so we've just basically cut one off, and I'll just trim that off a bit, and then we're going to solder that to the board. We've got our earth clip. Just surprised that they supply you with a yellow earth clip. But anyway, an earth clip is an earth clip, so we'll use that. That's what they supplied, and that just solders into one point there, and that'll actually come out that way on the board, and you'll have a heat shrink going up from basically the front of the board just to the back of the LEDs there. So the important point is make sure your IC orientated the right way, and with these you tend to have to adjust the pins a bit so that they fit into the IC socket, and then you should be able to just press that down. And if you do it right, they should all just slide in nice and evenly, and there shouldn't be any bends. So after all the soldering, we'll just go through and clean all the flux off the board. Before you put this heat shrink on here, which basically goes from there to there to the front of the board, we've got to trim that off a bit. There's a couple of tests that you've got to do just to confirm that the unit is working before you put the heat shrink on. The first one is just to switch it on, and when you switch it on, what should happen is the green light here should come on. We've got the green light on, switch it off, it goes off, switch it on, it goes on. Right, the next test that you do is check between ground, so that's your ground point there, and pin 3 on the IC, and it should be at a low potential. So I attach the ground connector to the negative lead, and we go to pin 3, 1, 2, 3, and you see there you're getting about 480 millivolts. So about half a volt is sitting on pin 3. Then the next test that you do is to short out the probe tip. So you just get a cable attached to the probe tip, and just touch that onto the positive side of the battery. And what should happen here is that the red light should go on, and when you remove it, it'll flick back to green, but you should just see the yellow flash. It's pretty quick, so it's hard to pick up, but you can see there, and it's pretty hard to see the actual yellow, but because it happens so quick. But again, I touch the positive side of the battery, it goes red. You can see the yellow flashing there. We've put the heat shrink onto the board. We've basically cut it to length. We just left that gap in there so we can have a bit of space in this area here. So what we have here is a function generator, and what we're going to do here is set that for 10 Hertz. It's on a square wave pulse, and if you put that on there, you can see it picking up the pulse. So that basically proves that the probe is working. If I increase the frequency to 100 Hertz, you can see there, just it's faster, but you can still see the pulsing action. And if I go up to 1K, which is getting a bit fast for it, the situation is that all the LEDs appear to be lighting up, but it's still indicating that you have a pulse there, but at a higher frequency. So that's at 10 Hertz again. So if I do fine control on frequency, you can see that it's getting a little bit faster as I turn it up on the 10 Hertz. And there you go, it's all the way up. So it's over 100 Hertz now. Wind the fine back, sitting on 10 Hertz. The situation is that if you have a fault in the circuit, so I can create a fault, I can just put that onto right sine or triangle wave output, and you should get the red light coming on. You can see there that it's just showing the red light, it's not picking up a pulse.